Action.
Oh, yeah.
So the topic is called expected value or expected payout. Question: how many of you, when you turn 18, are down at Treasure Island immediately? One of you? You were there this weekend. There you go. How about 21? The day you're 21, you're out in Vegas. All right. Somebody look this up for me first hour. The slot machines in Vegas, by law, have to pay out 75%. And actually, they want to pay out 75% because they want people to keep playing. If they lose, people are going to stop playing. So they want this to happen. So what we're going to do is something called expected value. And here's the deal. We've got a charity. It's a good charity. They're doing good works. And the charity wants money from you, but they don't want just a donation. They're going to give you a chance to win some money, all right, and at the same time, they're hoping to make money. And so it's just going to be a simple game. We're going to flip two coins. And just a reminder from a while ago, super easy. The first coin could be a heads or tails, the second heads or tails, which means you could get both heads, you could get a head-tail, you could get a tail-head, or you could get a tail-tail. And the coins look the same. So is there any difference between the tail-head and the head-tail? And if we're reminding ourselves, the probability then that you get two heads is the fraction, easy, what is it? 1 out of 4. Thank you, the three of you paying attention. Those of you on your phone should really quit. The probability of getting a heads and tails is 2 out of 4. I'll go around 1/2. And the probability of two tails is 1/4. All right, that was the basic, easy stuff from the start of this chapter. All right, here's what the charity is going to do. You're going to pay $5 to flip two coins. If you get a head-head, they will pay you back $1. Remember, it's a charity. They're trying to make some money, okay? If you get a head-tail, they're going to pay you $0. If you get a tail-tail, they're going to pay you $10. So what they're hoping is, first of all, that the charity is hoping to make money for the charity so they can do good things with their charity money. But they also want there to be enough of an incentive that people will play. You're thinking, hey, go ahead, and could win $10. So it'd be like a profit of 5 for you. So we are talking about you, okay? This is about you, not about the charity. Will you expect to make or lose money? We also could talk about the charity. Is the charity expecting to make or lose money? We're talking about you. All right, so here's your payout. 1/4 of the time, you're going to get paid that's going to be weird. You're going to get paid $1. Real quick, 1/4 is what decimal? In just a moment, 0.25 times 1 is going to be how much money? A quarter. Cool. Well, half of the time, you're expecting a payout of 0. And if you get two tails, they're going to pay you $10. So 1/4 of the time, you're going to get paid $10. So your payout is a quarter plus nothing plus, hey, let's do this in our head. A quarter is what decimal? 0.25. 0.25 times 10 is easy. It's what? $2.25. $2.50, thank you very much. $2.50, right? Cool. All right. We are talking for you now. We're talking for you. Your expected payout is the following. Your payout is going to be, you're going to make $2.75, but you are losing $5 because that's what you're paying. You would expect every time to lose $2.25. Because you could make some money, you could lose some money, you lose $2.25. Now, why would anyone ever do this? Because it's a charity. That's why I'm going to do it. Okay? I don't think anyone would do a game like this in Vegas or Treasure Island because they would lose too much money. But people would be willing to do it because it's a charity. Hey, maybe I could win a little, and if not, it goes to charity. There's going to be a second problem. There's going to be a second problem that's going to have 3 coins. And just a reminder of the 3 coins. They could go head, head, head. They could go head, head, tail. They could go head, tail, head. They could go head, tail, tail. They could go tail, tail, tail. They could be tail, tail, heads. They could be tail, heads, tails. They could be tails, heads, heads. 8 things could happen, reminding you from one of the first days of class. So the probability of 3 heads, how many are there here? 1 out of 8. So if you're doing a similar problem, 3 heads is going to be 1/8. 2 heads and a tail, here, here, here. Probability of 2 heads, 1 tail is 3 out of 8, and etc., etc. Okay, cool. Let's go. Let's go to the next one. Cards. Who can shout out immediately? Remember, how many cards in a standard deck?
52.
52 people win. Who can name the 4 suits?
Diamonds, hearts, clubs, and spades.
Some of you could. How many can name the face cards? Jack, queen, queen. Jack, queen, king. Ace is not considered a face card. All right. Cool. Can you, in this class, even during tests, come back and ask how many cards there are?
Yes.
Yes, okay, you don't have to know about this. All right, so there's going to be the following. There's going to be another kind of game, and here's what it's going to do. You're just going to pick 1 card. When you play the second time, it'll be replaced, okay? So it'll be reshuffled and everything like this. All right, if you pick a club, you'll get paid $10. Not bad. If you pick a jack, queen, or king that is not a club, you get paid $20. If you pick anything else, you will have to pay $15. It costs nothing to play this game. It costs nothing. Pick a card. Boom. It's a club, $10. There you go. Put it back in, reshuffle it. Hey, it's a queen of hearts. Yay, cool. Yay, I get $20. Hey, it's a 7 of not clubs. Got to pay him $15. Let's see if this is a game that should be played or should not be played from your point of view, All right, so we're doing the probability of a club. First of all, those that know, how many clubs are there?
13.
13. How many cards total? We've just said that out loud. 52. Some of you know immediately what fraction that becomes. That quickly becomes 1/4. Cool. All right, the problem of jack, queen, king that are not a club. All right, how many jacks are there total? 4. How many of them are not clubs? 3. So we got 3 plus 3 plus 3. Are there 9 jack, queen, and kings? They're not clubs? Probably that happens as 9 out of 52. Problem of anything else? Well, let's see. There's 13. There's 9. That's 22. No calculator. 52 minus 22 is 30. So here are our probabilities. 1/4 or 13 out of 52 that you pick a club. 9 out of 52 times you'll pick a jack, queen, king that's not a club. And 30 out of 52 you'll pick something else. We're talking this from your point of view. Here's our payout. It is going to pay 1/4 of the time. It is going to pay $10. You are going to add 9 50-seconds of the time. You're going to get $20. And 30 50-seconds of the time, you are going to lose $15. You're going to get money, you're going to lose money. You can do this one without a calculator. In this case, expected each time, 9 out of 52 would be $3.46. And then you are expecting to lose 30 out of 52 times $15, which is $8.65. So on each play, what you'd be expected, the probabilities, the average of the expected payout would be to make 2.5, add that to 3.46, but then you're expected to lose 8.65. You are expected to lose $2.69 every time you play. If this is some game in Vegas, you should probably choose not to. If it's a charity and you know that your money would be going to charity, maybe you would. Very, very nice, very cool.